In this video, we're going to be describing 6 trigonometric functions. We're going to start off by writing their ratios. Then we'll be able to use them to solve for an unknown side length or an unknown angle measure. All right, to start off with, we're dealing with a right triangle. In that right triangle, we're going to focus on one of these acute angles. Relative to that angle, you're going to be able to label the sides as either opposite, adjacent, or hypotenuse. So again, relative to this angle, across from that angle will be your opposite side length. The adjacent side is going to be the side that is next to your angle. And maybe you might be thinking that there are 2 sides next to the angle, but we already have a name for this other one. This is always called the hypotenuse, and that's always across from the right angle or the 90 degrees. If we can label those pieces, then we can plug in values into these equations. The first function is called the sine function. On your calculator, they take the e off. It's not sin, it's actually pronounced sine. The sine of an angle, for example this angle, is going to be equal to a ratio describing or comparing the opposite side to the hypotenuse side. The next function is called the cosine function, and you'll notice on your calculator that it is shortened to COS. The cosine function of an angle is going to be equal to a ratio comparing the adjacent side to the hypotenuse side. And a third type of function is called the tangent function. On a calculator, it's shortened to TAN. So the tangent of an angle is going to be equal to the ratio comparing the opposite to the adjacent sides. And looking at those 3 functions, there are 3 more functions that we can talk about that are called reciprocal functions. And so what we're going to be doing is just taking this ratio and flipping it. That's a reciprocal. So you'll notice right here that the reciprocal of sine is cosecant. It's shortened to CSC. And notice that the ratio is just the reciprocal of the sine ratio. Secant is going to be the reciprocal of cosine. And cosine was adjacent over hypotenuse, so secant is going to be hypotenuse over adjacent. And cotangent is going to be the reciprocal of tangent. Tangent was opposite over adjacent, so cotangent is going to be adjacent over hypotenuse. Sorry, adjacent over opposite. I can read. All right, so there are the 6 trig functions. It may be a little confusing to remember which is the reciprocal function of sine and cosine. Common mistake is to mix these up. If it helps, the way that I remember it is I have an S here for sine, and its reciprocal is going to start with a C, and it's going to be cosecant. Over here I have cosine, or a C, and its reciprocal is the S, the secant. So I remember that S and C goes together. So sine and cosecant, and then cosine and secant. Whatever works, try and come up with a method in your own head that helps you remember which is the reciprocal function of which so that you don't mix them up. Tangent and cotangent is hopefully not a problem. Those are named pretty easily. There is an acronym to help us with those 3 main trig functions, sine, cosine, and tangent. If you're not familiar, SOHCAHTOA is something you can say over and over in your head to help you remember, because it helps figure out which side lengths go with which function. So opposite and hypotenuse go with sine, adjacent and hypotenuse go with cosine, and opposite and adjacent go with tangent. So another way that you can remember these, come up with your own mnemonic devices or whatever helps. All right, we're going to practice writing those ratios. A fancy way of saying that is find the value of a trig function. So if I want to find the value of my sine function, I'm not solving for a side length, I'm not solving for an angle measure, I'm writing the ratio comparing the 2 sides for that particular function. In some examples, you may be given a right triangle, Oftentimes, at least at the pre-calculus level, you might be given two of those sides, but remember that our trig functions involve two of each of these sides. So we need to make sure to know all three sides in order to answer questions that involve ratios of either of these trig functions. So thinking back to geometry, we could solve a right triangle and find the third side if we're given two sides by using the Pythagorean theorem. We know that the leg squared plus the other leg squared equals the hypotenuse squared. Maybe you're already bored with that and you want to solve or use an equation that solves for hypotenuse. Well, that just means that you're just going to square root both sides. So the hypotenuse is always going to be equal to the sum of the squares of the legs, and you square root it. So 4 squared is going to be 16, 7 squared is 49. Add those squares and we get 65. So the hypotenuse length must be whatever the square root of 65 is. Keep it in that radical form. We don't want to use the decimal form and approximate it. This is the most accurate way to represent that length. Also make sure when you're using your Pythagorean theorem that you do exponents before you add. Common mistake is to add those exponent values and then square. Make sure you don't do that. All right, so now that we have all three lengths, we can figure out our ratios for any of these trig functions. For example, sine of an angle is going to be equal to opposite over hypotenuse. So if we say that angle A is going to be our angle of reference, then relative to that angle, this side length, BC, is going to be the opposite side. AB, of course, is going to be the hypotenuse. So writing that ratio of 7 over the square root of 65 gives us the ratio, but that's not considered a simplified ratio. We don't want radicals in the denominator. So we're going to rationalize. We rationalize a square root by squaring it or multiplying it by itself. So if we multiply the bottom by the square root of 65, well, to keep that balanced in math, we need to make sure and multiply the top by the exact same thing. Really what we're multiplying by is 1 here. So we're not changing the value, we're just changing the way that our ratio looks. So we're moving that square root of 65 up to the top. Squaring the square root on the bottom just leaves us with the number underneath. And so there's our simplified ratio form of it. Cosine is going to be comparing adjacent and hypotenuse sides. So relative to angle A, the adjacent side is AC, the value of 4. Compared to the hypotenuse again. So 4 over the square root of 65. One more time, we need to rationalize that. If you notice the pattern that happened here, that radical value just got moved to the top, and the value inside the radical was rewritten without the radical. So maybe the more you get used to doing these sorts of problems, you can think about that rationalizing in your head and jump straight from here to here. Not all of your ratios are as complicated. Just depends on the information given. Tangent is just comparing opposite to adjacent. So opposite from angle A is 7 and adjacent is 4. So there's a nicer looking ratio right there. Our reciprocal functions are pretty easy once you have these three main functions, because all you need to do is flip the ratios that you already described. Just make sure that you don't mix up secant and cosecant. Secant is going to correspond with cosine, so the reciprocal of cosine is going to be the square root of 65 over 4. Make sure that you don't use this ratio that you rationalized, because when you flip it, you're going to drop that radical back to the denominator and you're going to have to rationalize again, essentially undoing the steps that you did here. Save yourself some time, just go back to that original ratio and flip that one and you're good to go. Cosecant is the reciprocal of sine. So going back to that original ratio we said for sine and flipping it, we get the square root of 65 over 7. For cotangent, we're going to flip tangent. So flipping 7 over 4 becomes 4 over 7. So there's one way that we can find values of a trig function given a right triangle with some lengths on it. Let's take away the right triangle this time, and let's just start with one of these ratios. Well, if we want to think this way, it still might be helpful to visualize a right triangle. So we're going to take the ratio that we're given, and we're going to fill in a triangle based on those values. So since we're given the cosine ratio, that must mean that we're given the adjacent and hypotenuse lengths in this ratio. So if I sketch out a right triangle, doesn't matter how it's positioned or oriented, and I pick one of those acute angles to call my reference angle. Again, it doesn't matter. Wherever you put it, you're going to determine what the adjacent, hypotenuse, and opposite sides are relative to that spot. So I decided I'm going to put it right here. So that means that adjacent to this angle is going to be this length. That's going to be the square root of 3. And my hypotenuse with a length of 2 is going to go right here. So what I'm not knowing at the moment is what the length of my opposite side is. So just think back to what we just did. We have a right triangle with 2 side lengths. We can use Pythagorean theorem to solve for that third side length. So we're going to say that this unknown length is x, so x squared plus this side length squared, the square root of 3 squared, is equal to the hypotenuse squared, or 2 squared. You could simplify this and solve for x as it is. Another way to think about that, if we're missing a leg though, if we go back up here and look at our shortcut here, we said that to find the hypotenuse we take the leg squared plus the leg squared. Well, if we want to find a leg, what we could do is take the hypotenuse squared and subtract the leg squared. And if we square root that, that'll give us the value of this other leg. I chose to do it this way just because it seems a little straightforward and easy. So the square root of the square root of 3 squared is going to undo my square root, leave me with 3. 2 squared is 4 if I subtract 3 from both sides. Again, subtracting the leg squared from the hypotenuse squared. And then square root both sides, I get a length of 1. So now that I have all 3 lengths, I can fill out my ratios. The sine ratio is going to be opposite over hypotenuse. So opposite for my angle is 1, hypotenuse is 2, 1 over 2. Tangent is going to be opposite over adjacent. So opposite is 1, adjacent is the square root of 3. Rationalize, take that square root, move it to the top, and undo the square root on the bottom. For our reciprocal functions, secant is the reciprocal of cosine. So if I flip this ratio, I get 2 over the square root of 3. Once again, rationalize, move the square root to the top, and undo the square root on the bottom. Cosecant is the reciprocal of sine. Flipping 1 over 2 gives us 2, or 2 over 1. And cotangent, again, don't take this that you rationalize, but go back to that first ratio that you decided and just flip that one, so we get the square root of 3. All right, so how can we use these trig functions to help us solve for unknown lengths or unknown angle measures? Hopefully you've done this in geometry, so hopefully this is just a review. Based on the information given this angle measure, let's label our right triangle based on whether they're opposite, adjacent, or hypotenuse sides relative to the angle. Across from would be the opposite, next to would be adjacent, and the hypotenuse is across from the right angle. So using these two pieces, hypotenuse and adjacent, and the angle, which trig function do we need? So think about our acronym here, if that helps. What goes with adjacent and hypotenuse is cosine. So we're going to use the cosine function. We're going to substitute what we know into this equation right here. Cosine of the angle equals adjacent over hypotenuse. We're going to substitute the angle measure there and the hypotenuse, and we're going to solve for adjacent. So the angle is 70. We got the cosine of 70 degrees equals the adjacent side, which we don't know. We could say it's x if you want, and the hypotenuse, 5. To solve for BC, we need to undo this division of 5, so let's multiply both sides by 5. So the side length must be whatever 5 times the cosine of 70 degrees is. Use your calculator. Make sure that you are in degree mode. If you need to, go into your mode and make sure that degree is highlighted or selected. And then you can type it all out. 5 times cosine of 70, and it should give you this decimal approximation, about 1.7. We're here in part B. Relative to the angle of 35 degrees, we're asked to find the opposite side, and we're given the hypotenuse side. So what goes with opposite and hypotenuse in our acronym is sine. That's our SO part of our acronym, SOH. So the sine of 35 degrees is going to be equal to the opposite, or AC, over the hypotenuse, or 5. One more time, just undoing that division of 5, multiplying both sides by 5. 5 times the sine of 35 degrees should give you about 2.8 or 2.9. So there's our side length for AC. So that's how we find side lengths. Use those equations, plug in the angle and one of the side lengths that you know. Here's how we can solve for an angle measurement if we don't know what that is. These are called inverse trig functions. This little -1 above our function is the inverse symbol. Maybe you remember that from the first semester. So trig functions also have inverse functions. Remember that inverse functions undo its other function, the inverse. So if we take this equation, for example, sine, and we want to get to that angle, we want to undo the sine function. So if we inverse sine both sides, that'll cancel sine and we'll be left with angle. But now we have the inverse sine of our ratio on the other side. So opposite over hypotenuse. Again, it's just pressing those buttons on your calculator. The inverse trig functions are probably a secondary feature. You may have to hit second or shift on your calculator to get them. But other than that, you're just plugging in the ratio values and hitting enter or equals, and it tells you the angle measure. As long as you're in degrees, it'll tell you the degree measure. Notice that the ratios for sine, cosine, and tangent haven't changed. Sine is still opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All right, so given this example, we'll be able to solve for the measurement of angle A and B. We know that angle C is 90 degrees. Can't use trigonometry, well, this type of trig without a right triangle. So of course we have a right triangle. What sides are we given based on being at angle A or using angle A? Relative to angle A, we have the adjacent side and we have the hypotenuse. So we know that cosine goes with adjacent and hypotenuse. So on your calculator, type in the inverse cosine of 14 divided by 21, which is also equal to 2 over 3. So you can sometimes reduce your ratio. That won't change the value. And hopefully your calculator tells you it's about 48 degrees. So if angle A is 48 degrees, one way that we can find angle B is just knowing that these two angles are complements, adding up to 90, so we could subtract what we know from 90. So 90 minus 48.2 is going to give us 41.8 degrees. Although we could still use trig, but this time be careful, because if we're using angle B or setting things up relative to angle B, then this side over here is the opposite side, and this is still hypotenuse. So we want to make sure and use sine because that goes with opposite and hypotenuse. And if you do that, you should get the same measure. One more time in part B here. Relative to angle B, we are given the opposite and adjacent sides. We know the opposite and adjacent goes with tangent. So if we use the inverse tangent of our ratio 4/7, we should get the measurement for angle B. And we get about 29 or 30 degrees. All right, so there's how we can use trig functions. We can use them to solve for unknown angles in right triangles. We can use them to find unknown side lengths as long as we have at least one angle in one side. And we can use them to write ratios of all of our other trig functions. So good luck practicing.